Today, I'm going to explain what the squeeze or sandwich theorem is. The squeeze theorem is used to find the limit for a function f of x and states that if on an interval a to b, f of x is always greater than or equal to a function g of x and less than or equal to a function h of x, and the limit of g of x as x approaches a number c is equal to the limit of h of x as x approaches the value c, and that's equal to a number we'll call L. Then that means that the limit of f of x as x approaches that value c is also equal to L. So let me draw a graph here so you can visualize the situation better. I have the interval a to b. So first I'll draw the lower function g of x, and then the higher function h of x, and then the function in the middle, f of x. And you'll notice that at this one value, the point we'll call c, they all approach the same value, so they all have the same limit. So I'll show a quick example to demonstrate this theorem. Let's set f of x equal to the equation sine of x over x. So first let's try to find the limit for this by plugging it in. First we're trying to find the limit of f of x as x approaches 0. And if we try to solve this by plugging in 0, it'll just be sine of 0 over 0, which is just 0 over 0. So that's indeterminate. So we need to find another way to find the limit. Well, we already know that when x is close to 0, sine of x over x is less than or equal to 1 and greater than or equal to cosine of x. And if you want to confirm the validity of that, you can search for a proof on the internet. But anyway, the limit of 1 as x approaches 0 is 1. And the limit of cosine x as x approaches 0 is also 1. So since that's true, that means the limit of sine of x over x as x approaches 0 must be 1, since sine of x over x is always between 1 and cosine of x. So using the squeeze theorem, we were able to determine that the limit of sine of x over x as x approaches 0 is 1.